It's week 9, and we're finally ready to talk about markets. We spent a long time talking about consumer choice to derive demand. Then we talked about cost and production to derive supply. And now we're ready to bring it together to talk about a perfectly competitive market. Our focus here is still on firm behavior and describing firm behavior within the context of a perfectly competitive market. And as we move forward after the next exam, we will be talking about firm behavior in different types of markets. But for now, we're going to focus on perfect competition and how firms seek to maximize profits in the context of a perfectly competitive market. So note that firms always want to maximize profits. That is the goal of every firm. So we will be seeking to maximize profits, not just in perfect competition, but in the context of every market. So the first thing we probably should do is remember what profit is. Profit is total revenue, all the money you earn, minus total cost. And what's left over is your profit. And so like I said, all firms aim to maximize their profits, and now we can put that into the context of a maximization problem. So if we want to maximize profits, we will be choosing the quantity that gives us the highest value for this function. So we would write total revenue as a function of quantity produced, total cost as a function of quantity produced, and then find the maximum of that function. The choice of quantity that gives us the highest value for profit. Notice that we don't have constrained optimization here. There's no plus lambda resource constraint. So this is an unconstrained optimization problem for now. Okay. Which means that we're just going to take the derivative and set it equal to 0. Right? Find the point along the function where the slope is equal to 0, and that will tell us where the maximum is. So when I take the derivative of total revenue with respect to quantity, and then total cost with respect to quantity, and I set that equal to 0, then I get that marginal revenue minus marginal cost is equal to 0, or in other words, marginal revenue, the slope of the total revenue function, is equal to marginal cost, the slope of the total cost function. And this is going to be true for all firms, not just firms in competitive markets, but for all firms. They will want to produce as long as marginal revenue, the additional revenue from one additional unit, is higher than marginal cost, the cost of producing that unit. So as long as you're bringing in more money than your cost, you're going to be increasing your profit, and you continue to produce until that's no longer true, and then you stop. Okay, so I want to show that to you graphically, but before we do, I want to just talk a little bit about characteristics now of perfectly competitive market and how we think about profit maximization in this special context. So in perfect competition, we are assuming that we have many buyers and sellers, that each firm and each consumer is a very small part of a big market. And that means that individual choices, both of production and of consumption, are not going to affect the market price. Like whether or not I buy apples at the grocery store is probably not going to increase or decrease the price of apples for everyone because I am just one consumer in this huge market for apples. Of course, collective consumer behavior, total demand for apples, determines the price of apples or helps determine the price of apples along with supply, but my individual choices aren't going to move the needle. And that's what we're going to assume here, both for buyers and sellers. So the choice of one individual seller to produce a couple more units or a couple less units is not going to change the market price. We also assume that all the products that are produced in this market are identical. So like every firm is making an identical product. And therefore, from a consumer perspective, they don't really care which firm they buy from, right? Like I could buy from firm A or firm B, their products are identical. I don't really care. The only thing I really care about in that decision is price. And so because we've got all these little firms and they all make exactly the same product, they have no control over their price. So these two assumptions mean that firms are price takers. They just observe the market price for their product, and then they make their production decision. They have no control over the price. They have no influence over the price. They just take the price as given. We also assume that consumers have perfect information about prices. So like I know what the price at all the different firms is, meaning that we're going to have one prevailing price on the market. Okay, there's no opportunity for one firm to have a higher price than another firm, because if one firm has a higher price for the same product as another firm, nobody's going to buy from them. All the consumers know they can get it cheaper from this other person. And so demand for the higher priced firm's product would go to zero. So that means that there's just one price. The firms take the price as given. And these are unique characteristics of a perfectly competitive market. The last one, the no barriers to entry and exit, really has more to do with long run firm behavior. So we'll talk about how firms behave in the short run, observing the price and making their production choice. And then we'll also talk about how firms behave in the long run. How do we decide whether or not to go out of business, or maybe to open a firm in this market, entry and exit. So we have low barriers to entry or exit, which you might remember from your intro class, in the long run is going to push profit to zero. So these are the assumptions that we make for perfect competition. And again, we'll relax these assumptions later as we talk about monopoly and oligopoly markets. But for now, we'll start here. So firms observe the price and take the price as given. I want to show you on the graph what that looks like and then how that relates back to our profit maximization problem. So I've got a couple graphs here, and I want you to notice first that I have a little lowercase q on the x-axis, and I've got a subscript I. So when we make the lowercase q, that's going to stand for an individual firm's quantity, whereas uppercase Q would stand for the quantity in the market. So we'll distinguish those now. And the I is the kind of which firm, okay? So this is the quantity for firm I. And I, of course, could be 1, 2, 3, 4, 5, however many firms we have in the market, but just generically one individual firm here. And we want to think about this firm's production choice in terms of that marginal revenue, marginal cost trade-off. So we've spent some time now making our cost curves. We know marginal cost should be upward sloping. I'm just going to start it here at 0 for simplicity. And we've got some marginal cost for firm I. And this is really the supply curve for firm I. And I'll show you why that is here in a minute. Supply is the relationship between the price and the quantity that the firm wants to produce, right? So this is going to be the individual firm's supply curve. And then what does demand for this firm's product look like? Demand for the individual firm in a perfectly competitive market is perfectly elastic. In other words, it's just a horizontal line here across at the market equilibrium price. So here we have demand for firm I. It's the same as marginal revenue, and it's equal to the price. Why is that? It's because if you simply take the price as given and the quantity that you produce has no influence over the price, then every unit you sell earns you revenue equal to the market price. If I'm selling apples and the price of apples on the market is $2 a pound, then every pound of apples I sell, I'm going to earn $2. Right? The marginal revenue there is just constant at $2 because no matter how many pounds of apples I sell as a small apple farmer, it's not going to move the needle on the price. So we've got this constant marginal revenue equal to the market equilibrium price. And we can also think of that as demand. Consumers are willing to buy from me as long as my price is equal to the market price. As soon as I raise my price to $2.05 a pound, no one is going to buy from me. They're just going to buy from the farmer next door. So I've got perfectly elastic demand for the individual firm equal to the market price here. And this is what you were doing in your intro classes as well. We observe the price, we come across, we maximize profit where price is equal to marginal cost. And that's the piece that I want to talk about now. Why is it that we maximize profit here where price is equal to marginal cost? So on this graph down below, I'm going to try to show the profit function rather than our marginal functions to show you what's going on here. So I know that if I sell a quantity of 0, well, I'm not going to earn any money. My profit is going to be 0, assuming that there's no fixed cost. Otherwise, my profit would be negative there. But let's just assume this is simple, no fixed cost. And if I sell nothing, I get no money and my profit is 0. So now what does profit do after this? Well, you can see as I begin to sell apples or whatever it is I'm selling, my marginal revenue here is higher than my marginal cost. So for each additional unit I sell, my revenue is higher than my cost, so my profit is increasing. Okay, until we get to this point here, where the additional revenue from each unit is equal to the cost. So at this point, selling that marginal unit would result in 0 profit because the revenue is equal to the cost. And that's the point here where my profit function is maximized. And after that, if I kept selling more, now you can see my marginal cost function is higher than my marginal revenue function. That's not good. That means the cost of producing these units is higher than the revenue I earn. So selling them would decrease my profit until we got again to 0. And this would actually be the point here where price is equal to average total cost. The price or the revenue per unit was equal to the average cost per unit. Okay, so what we're doing in our maximization problem is actually writing out the profit function and finding the point where the slope is equal to 0, right? When we take the derivative and set it equal to 0, we're finding this point where slope is equal to 0 to maximize profits. Another way of seeing that is that this is going to be the point where the slope of the revenue function is equal to the slope of the cost function. In other words, marginal revenue is equal to marginal cost. And this will be true for all firms, that marginal revenue will be equal to marginal cost. But perfect competition is kind of a special case where our marginal revenue is simply equal to the price. It's constant and equal to the market price. So in perfect competition, our maximum profit occurs where price is equal to marginal cost, because in perfect competition, price is equal to marginal revenue. Okay, and maybe you remember that from your intro class a little bit. Hopefully it sounds familiar, but we're trying to kind of see where all of this stuff comes from.